All right, everybody, welcome to Chapter 4, The Structure of the Atom. Mrs. Kelly and I are going to be talking to you about a lot of history on chemistry, how we got to where we are today. So be ready to write things down in your notes. Again, pause us when needed, rewind us, anything that you want, because you want to listen to us a lot. So here we go. To start everything off, we had some philosophers. They weren't really scientists back then. Everybody was philosophers. They talked about everything from English and nature and weather and government. And then Aristotle was the most famous one at that point in time. He was what we like to call the top dog philosopher of the time. He came in, and this is his wonderful statue. I can tell that he was very influential in that time period because of all the detail in his statue. I try to make this connection because of the next person we're going to talk about, but at that point in time in history, Aristotle thought that there were 4 elements, Mrs. Kelly. They are?
Okay. Earth, wind, fire, and what am I forgetting? Water. Water.
The water one. Now, out of those 4 elements, they thought that they could form anything. So everything that they saw around them was made up of those 4 elements, and that's it. So at that point in time, everybody wanted to make gold because gold was your currency. And if you could make gold out of those 4 elements, then you could be rich beyond your wildest dreams and you can pretty much control everything. So, Mrs. Kelly, those people that tried to make gold out of those 4 elements were called what?
Alchemists.
Those alchemists like to blow themselves up because what they did is they would mix these things, unbeknownst to themselves, in poisonous mixtures, in gaseous mixtures, and some just exploded. They didn't live long. Now, alchemists, all right, we got to go to the next philosopher, though. This guy, notice the difference in detail. He doesn't really have shoulders or an outfit. His name is Democritus.
Or eyeballs.
Oh, yeah. Democritus was the first person to challenge Aristotle, and he proposed that there were tiny particles called atomos. Those atoms, the atomos, we call them atoms today. Aristotle laughed at him, which means everybody else laughed at him, and Aristotle won. So Democritus and his theory of the atomos got pushed back, thousands of years, until this guy showed up. Mrs. Kelly, you want to talk about Dalton?
Well, John Dalton, he loved gas. So he studied properties of gases, and we'll talk in chapter 12 about partial pressure law. So just keep in mind that that's Dalton when we get there. And how they interact with each other, he came up with his atomic theory. Now, Dalton, notice he's an old white guy, like most of the scientists at the time. He was educated, and a lot of people really respected him. So his atomic theory consisted of 6 different parts. So the first one is matter is composed of extremely small particles called atoms. He got that from Democritus. Number 2, atoms are indivisible and indestructible. So he thought they were solid spheres and they could not be divided. So make sure that you're keeping track in your notes and pause if you need to write these down. But you need to write down all of Dalton's theory. Okay, number 3, atoms of a given element are identical in size, mass, and chemical properties. So he suggested that all of the hydrogen atoms are going to be the same size, the same mass, and same chemical properties. And the same for any calcium or boron, anything like that. Number 4, atoms of specific element are different from those of another element. So he said hydrogen was different than helium, and that was also different than lithium. Number 5, different atoms combine in simple whole number ratios to form compounds. So because they cannot be divided and they're indestructible, you cannot add half an atom to another type of atom. They have to be combined in whole numbers. And we will get into conservation of mass in what chapter?
Very soon.
Very soon. And we've talked about this in Science 1. So if you had me in Science 1, this is not a surprise. But conservation of mass, you have to start with the same number of atoms and end with the same number of atoms. And number 6, in a chemical reactions, atoms are separated, combined, or rearranged. But the atoms themselves are typically not separated.
Nice. All right, so we're going to move on to the cathode ray in 1897. Another famous scientist, J.J. Thomson, was huge in chemistry history. What he ended up finding was he was the first of the subatomic particles to be introduced. He found the electron using a cathode ray tube and a ray that was bent using magnets. We have a video later on that you can watch and see how this was actually done. It's pretty cool. He discovered that the mass of an electron to be smaller than the smallest atom, making the part of Dalton's theory incorrect. There were subatomic particles. Nowadays, we even know that there are even subatomic particles that make up everything else. You've got your quarks and your other fun little things, which we will not go into in class. You would have to take an advanced chemistry class to do that one. So J.J. Thomson, we move on. He did the electron. Robert Millikan, a few years later in 1909, used an oil drop experiment. He found that the charge of a single electron to be a -1 and that the mass to be 0.602 times 10 to the -19 coulombs. New introduction on that term. Don't be too worried about it. So now what does the atom look like if we have positive protons and negative electrons? Well, we have the plum pudding model, which none of you have ever seen plum pudding.
No.
I like to call it the chocolate chip cookie dough.
Me too.
Because we've all had chocolate chip cookies, and they're delicious. With that dough, so the dough is kind of like the positive pieces, holding in the chocolate chips, which are your negative portions of it. So J.J. Thomson proposed the plum pudding model with the pudding being the positive mass holding the plums of the electrons that are negative. That's your top pink one with the arrows going straight through. Ernest Rutherford, another famous chemist. His name will be announced many times when you go to college if you take a chemistry class. Ernest Rutherford found that his using gold foil, very thin gold foil, he used an experiment that was something in the middle. He found that there was something in the middle reflecting electrons backwards. And then he actually came up and named it as the nucleus. So if you're looking at the yellow picture, with that yellow picture, you'll now see that there's only one section in the middle that's positive. So when he sent through these beams, some at the top and the bottom made it straight through and were charged on that side. But then there were some that were shot off in very different angles, mostly in the center. And if you notice, then that center is completely missing. So we found out that there has to be a positive thing.
Okay, so let's review really fast. Dalton, he decided that there was an atom, it's indivisible, it's indestructible. He did not say anything about positives and negatives. Okay, the next one would have been J.J. Thomson. He decided that there are positives and negatives using his cathode ray. Millikan, what is his model?
He found that the charges was a -1.
Okay, and then we've got the plum pudding model. That is a positive sphere with negative electrons, and then we've got Rutherford. He has a condensed nucleus, and he thinks that the whole nucleus is just positively charged with a large area that has negative electrons in it. Okay, and now we're going to talk about the differences of protons and neutrons.
Yeah, because now in 1932, James Chadwick decided that now there has to be something in there, because let's talk here. We've got these charged particles. We've got particles. If you are the same charge, what are you going to do to each other?
If you're the same charge, then you're going to stay together, right?
Or are you going to repel each other?
Oh, you're going to repel each
Yeah.
other.
So if you've got the same
like
charge
two
things,
ends of a magnet.
yeah,
You have two positives
yes.
that they're going to push away.
There we go.
Got it.
So if we've got that going on, we're going to repel each other. Well, if your whole center is full of positive pieces, those positive pieces technically could not stay together. They have to repel each other based off of their like charges. So there has to be something in there buffering it. So James Chadwick found that there were inside that nucleus there are neutrons. Those are the things that are going to buffer our protons. So here's a chart that summarizes everything we've just learned. Our electron is an E negative symbol. So really short, so we don't have to write electron over and over again. Its charge is -1. It's really, really tiny. It's 1/1840. It is super, super small. And then its actual mass, even smaller, 9.11 times 10 to the -28. Then you've got your protons and your neutrons. Protons is a P plus. Neutron is an N with a 0. Notice the 0 because there's no charge. The charges then for proton is a +1. Its mass is 1. And then its actual mass is 1.673 times 10 to the negative 24th. Neutron is pretty much the same thing except the charge is different. It has no charge, which is great because then the protons aren't going to attract to it or repel it. It's just going to buffer those protons. Its mass is 1, and its actual mass is the exact same as a proton, which is wonderful. It works out perfectly in nature. Here at the end of this section, Mrs. Kelly and I have picked out some videos for you to watch to help you understand and see visually what the cathode ray, the oil drop, the gold foil, and a Chuck Norris gold foil, and then the new Higgs boson explained. The new Higgs boson came into play just this summer in 2012. So we've tried to give you an explanation of what that is so you're up to date on the new findings in chemistry. Enjoy!